Okay, in this video we're going to tackle problems 1 and 2 from test 7 review. So let's get this party started. Last test, we're excited. So something to notice about the first problem, they're both linear equations, and so when we're solving this we do need to set it equal to y equals mx plus b. It is the fastest way to graph a linear line. So I went ahead and did that for you. So I have y, I moved the 2 to the other side, so that gives me negative 2x minus 2. That gives me a slope of negative 2 over 1. I did this also for my second line. Second equation, you can see my algebra here. I divided by 3, moved my 6 over first, got the negative 6x, and then this is the equation. Notice in both equation 1 and equation 2, I get the same slope, negative 2 over 1. That's very, very important to note. Whenever you have the same slope, you in fact get parallel lines. Of course, you're welcome to put both of these into your graphing calculator. It too will yield the same table with these same points, and you get the same image. Here I just followed classic y equals mx plus b, down 2 over 1, down 2 over 1, which is my slope. And so notice we get parallel lines. What do we know about parallel lines? That's right, they're never ever going to intersect. And so that makes it where they don't have a solution. Remember, a solution is where they intersect. So the answer you want to put here is no solution. It doesn't have an answer. There's no place in time and space they're going to collide. And so it says if the system is dependent or inconsistent, state so. This is a classic case of inconsistent. Inconsistent means they're never going to touch. Inconsistent system. Never going to touch. Dependent is when they're the exact same line. They're right on top of each other. That's important. It does say solve graphically and substitution. I'm going to go ahead and cross this out. I'm not going to do it with substitution, only because we're going to spend quite a bit of time later on in other videos where we solve by substitution, so I think it's worth waiting. So here we have first problem. Second problem, we have another linear. How do I know they're linear? That's important to note. Notice there's no exponents, there's no square roots, there's no, like in this case, you see a lot of stuff going on here. So since there's nothing happening here on any of the variables, that means you just have your classic y equals mx plus b. This one I went ahead and started the same process. I moved my x over to the other side, but notice I have my leading coefficient is negative 1. You don't want that. So I'm going to go ahead and divide by negative 1. Why am I doing this? So that I can get my classic y equals mx plus b. And so I get a slope of 2 and I get a y-intercept of 0, negative 7. We'll graph him in a minute. We're going to call him equation 1. Equation 2 is really close to being solved for y. I just need to divide all my terms by 2. I get y equals 2 divided by 2 is 1x minus 3. So my slope here is 1 over 1. That's going to be up 1 over 1, and I get 0, negative 3 for my y-intercept. So I can clearly see that these are not going to be parallel lines, and they are definitely not the same line. So with deductive reasoning, we can see that they're going to meet in time and space. Our job is to figure out where exactly do they meet. And so let's get started. Equation 1, 0, negative 7's way down here. Up 2 over 1, up 2 over 1. You might be saying, well, how did I know to move over 1? That's a good question. Any whole number, you could just put it over 1. That still makes it 2, and we go up 2 over 1. Remember, slope is the ratio of the change horizontal over the vertical change, and so that's how we're getting the slope. Over here we have 0, negative 3. That's right here. Up 1 over 1, 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 up 1 over 1. We also could go down 1 to the left, down to the left. And so we just kind of connect the dots. I should have a straight edge, but I don't. And so here, just like we predicted, they're not parallel, and they're definitely not the same line. They do meet in time and space, and it looks like where they meet at is 4, 1. Anytime you're unsure and you're thinking, does it really meet right there? It's hard to tell. You could always plug in your x and your y value for both equations. It does have to satisfy both of them. Since this meets at 4, 1, it is not dependent or inconsistent. It is, in fact, a consistent. And what you want to put in your answer box is, of course, the ordered pair 4, 1. Hope this helps. Next video is going to tackle your friend and mine nonlinear versus linear and where those collide. This is problems 1 and 2.